Good afternoon, dear conference participant. The aim of the work was to analysis of the accuracy, stiffness, and stability of shell structure of mirror antennas using simulation modeling. Analysis of the accuracy, stiffness, and stability of shell structure of mirror antennas using simulating modeling. In the course of the work, the process of forming reflective shells and finding the position of grid elements after deformation was investigated. Fixation of mesh nodes by electric arc spraying. After that, a composite material such as polystyrene is applied to form reflective shells. Minimization of potential energy is carried out numerically by an iterative method. The result of the work is the formation of the antenna array shell by the method of electric arc spraying and the application of the composite material. The interaction of axisymmetric and non-axisymmetric shell and bending vibration form, which leads to the emergence of unstable forms of motion, is analyzed. The scheme of the mirror construction, spherical and cylindrical shells docked with a ring. The shell for the ring is a kind of elastic base that prevents its movement. The effect of the shell when considering the motion of the ring under the action of pulse pressure is taken into account by introducing contact forces of interaction, which are determined when solving the corresponding contact problems of the mating. The assessment of the stiffness strength characteristic of antennas of solid and reinforced structures is graphically represented, and the stress strain state is calculated under the action of wind load and gravity. Statement of the problem. The production of antenna system and the manufacture of reflective surface is based on new technological and design ideas, the implementation of which requires appropriate scientific and technical support and is possible in close cooperation between production and scientific potential. The technology of manufacturing mesh material shells can be used to produce axisymmetric and non-axisymmetric reflector or individual elements of mirror antennas. Purpose of the work. The main design and technological ideas implemented in antenna system are preserving the basic principles of aviation technology in the production of antennas and including the influence of subjective factors on product quality, optimization of structure according to the criteria of stiffness, accuracy, and weight, use without slipway assemble and on-site adjustment of antennas, use of factor diffraction method in optimizing the electrodynamic characteristic of an antenna system at the design stage. The antenna positioning control system control of its movement speed, diagnostic of its condition during operation, self-testing is based on digital information processing. The interaction of asymmetric and non-asymmetric shell and bending oscillation form, which leads to the emergence of unstable forms of motion, is investigated. The scheme of the mirror construction, spherical and cylindrical shells docked with a ring. The shell of the ring is a kind of elastic base that prevents its movement. The influence of the shell when considering the motion of the ring under the action of pulse pressure is taken into account by introducing contact forces of interaction which are determined when solving corresponding contact problems of the coupling. Operation of the satellite dish. Choosing satellite TV means having many channels in excellent resolution. Unlike cable TV, satellite TV is available everywhere. All you need is a satellite dish and a decoder. Installation and setup of the equipment is affordable. A satellite TV dish is used to receive a TV signal from a space satellite. The parameter of the dish itself and its converter largely determine the image and sound quality that the satellite decoder will produce on the TV screen. Um, an offset satellite TV antenna resembles a bowl and has an ellipsoidal shape. The signal from the satellite reflected from the working mirror are concentrated above the geometric center of the shape and its lower focus. A dish with a lower focus doesn't require large elevation angle. Such a mirror design in offset satellite dishes allows for more stable receptions since the signal converter doesn't cast a shadow on the surface of the dish and doesn't cast noise. Direct focus satellite dish, this type of wave receiver has a working mirror surface in the form of a flat-ended paraboloid. The symmetrical geometry of the reflector allows for good capture of radio waves arriving on its surface and their maximum redirection to the transducer. The reflector is mounted on the holder cantilevers directly above the center point of the dish. And now we can see offset satellite antenna, and we can see a direct focus satellite dish. In the study of the dynamic stability of antenna mirror in the form of a spherical segment which is bounded to a ring, the design is considered taking into account various factors and parameters. To harmonize solution, the concept of a cylindrical shell attached to the ring as an elastic base is considered. This allows us to take into account design features such as protection from external influences. And we can see an offset aluminum antenna with a thickness of 2 millimeters, front wide and side view. And we can see an offset aluminum antenna with a thickness of 2 millimeter, general wide of the antenna trimetry. The main stages of electric arc spraying are surface preparation, material preparation, electric arc spraying, cooling, and fixing. The surface to be coated must be thorough prepared, cleaned of dirt, oil, rust, and other contaminants, and may require grinding or other operation to improve the adhesion of the coating to the surface. The material to be applied is usually supplied in the form of wire or powder. It's melted in an electric arc to a very high temperature. The arc generates a very high temperature that melts the material and turns it into a liquid chip. The molten material is sprayed onto the prepared surface using a gas jet, usually argon or air. Upon contact with the surface, it quickly solidifies and forms a thin coating. After the coating is applied, the surface undergoes a cooling process during which the material is fixed to the surface. Additional processes such as heat treatment or ultrasonic treatment are usually used to achieve maximum coating strength. The results of the analysis of stress-strain state to variants of the offset antenna design were established. The safety factor of the offset antenna of the proposed design is 5.9 times 5.7 times less than that of the basic design, but greater than the minimum allowable safety factor of 1.5 for such designs. The normal stresses for the offset antenna of the proposed design are 4.5 times higher than those of the basic design and amount to 108 MPa. The maximum displacement of the upper edge of the offset antenna of the proposed design are 20 times greater than those of the basic design and amount to 62 millimeters, which completely prevents the normal operation of the antenna under the condition under considering wind speed of 20 meters slash second. And we can see a stress diagram, and we can see the safety factor diagram. And the obtained results of wind load research can be effectively used for patch antennas with elliptical slits and cyber physical biosensor system. Conclusion. The presented research examines offset antennas with the aim of unlocking their potential and improving their application in modern radio engineering system in the context of constant technological development and the growing need for communication. Offset antennas are coming to the fore as an effective and innovative solution. The paper deals with the problem of local stability under load. It's important to study the corresponding problems under the influence of an edge dynamic load arising from vibration of the antenna mirror and transmitted from the base. The dynamic stability of a mirror as a spherical segment bounded to a ring is investigated. For the sake of consistency, we assume that a cylindrical shell of a finite length is attached to the string, the case when the antenna mirror is made is the form of only one spherical shell is treated as a special case. The presence of a cylindrical shell is associated with a design solution to protect the antenna from external influences, such as an incoming flow. The motion that occurs after the application of the pulse consists of asymmetric vibration and bending vibrations associated with the inevitable deviations of the pulse from a uniform one. Thank you for your attention.